Subscribe our channel and press the bell icon so that you can watch our latest videos at very first.
Hey guys, welcome to my channel. In this video, I'm gonna solve a question which were asked in Amazon, FactSet, Goldman Sachs, Google, Microsoft and Paytm. This is a simple label question. I'm going to start a series of videos. In every video, I'm gonna solve one or two questions of MNC company. This is gonna help you how to solve a question of competitive programming, and if this type of question were asked in your interviews, then how you can approach these questions. So let's deep dive into the question web array. So what the question basically is, given a sorted array ARR of distinct integer. So what we are having a sorted array. Sort the array into a web like array and return it. What we have to do is we have to sort this sorted array into web like array and then return it. So what is the web like array sequence? The number 1 position element is greater than number 2 position element. Number 3 position element is greater than number 4 position element. Similarly, number 5 position element is greater than number 6 position element. And also the condition is number 2nd position element is less than number 3rd position element. So we already know the array is in sorted form, then automatically number 2nd position element is going to be less than number 3rd position element. So we don't have to check this condition. These are basically our approach. So what we are going to do is, let's suppose here is the question 1 2 3 4 5 and here is the output 2 1 4 3 5. So you can simply go through this input and output. What we are seeing is position of 1 and position of 2 were changed, position of 3 and position of 4 were changed. Similarly, position of 5 and position of 6 were changed, like this. So what we can do is, in this question we can simply interchange the position of 1st to 2nd, 3rd to 4th, 5th to 6th. So how can we do this? So here in public static void convert to wave, what we are getting are array and a size of an array. So let's suppose we have to interchange the position of an element into an array. So start with the for loop. In for loop we are going to iterate from int I is equal to 0, I less than n, and here what we are seeing is at the position 4 we are simply interchanging the 4 with 5 and we don't need to go to the position number 5. So we are going to iterate this loop to n minus 1, and also what we are seeing is we are changing 1st to 2nd and then 3rd to 4th. We don't have to iterate to the 2nd, 4th, this type of position. So what we can do is we can simply increment I as I is equal to I plus 2. In this question we have to solve this in order of n time complexity. We all know that a single for loop is of order of n time complexity, so we have to solve in the single for loop only. So we have to interchange the position. Let's create a temp variable. Int temp is equal to the value of position 1 into temp. So we all know that the indexing of array starts from 0, so 0 is actually a position 1 element. So we have to put position 1 element into a temp. Then what we can do is interchange position 2 element with position 1, and again we are going to replace position 2 with temp, and finally we have to return array. So what I have done is I have iterate the loop from 0 to n minus 1. Why n minus 1? Because we have to iterate to this position only, not to this position. And I am incrementing I with 2 because we have to iterating 0, then 2, then 4, then 6 in this manner. So then this is basically a code of interchanging a element. So if I is equal to 0, this position will be interchanged. If I is equal to 2, basically I becomes 2 in the second iteration. This will be changed. That is happening. So let's compile and run. Yeah, we get output as 21435. 2 is replaced with 1, 4 is replaced with 3, and 5 in that manner. Why I removed return ARR? Because we don't need to return in this, because the return type is word type. So can we further reduce this? Can we further? Now we can see the time complexity of this algo is O of n by 2, because we are incrementing I with 2, so the time complexity will be n by 2. So can we further reduce it? Let's check it. Here in this, what we are seeing is ARR of 1 is greater equal to ARR of 2. It means the value at position 0, it may be equal to position 1. So if the value of position 1 and position 2 is equal, then we don't need to interchange it, because if we interchange, then what we are getting? We are getting a same output. So what we can do is we can add a condition over here. If ARR of I is less than ARR of I plus 1, then only we have to interchange the positions. So what I have done is I am going to check if the element at position 1 is less than position 2. If our condition is true, then only it become interchanged. If it is equal or greater, then it's not going to be interchanged. We already know it is in shorted manner, so there will be no chance of this element to be greater to this, but a chances of equality is here. What we actually done is we reduce the time complexity of this algorithm further. Let's compile and run, and it will happening. Yeah, I'm getting same output as earlier. So that's all for this video, and in the very next video I'm solving another question which were asked in MNC companies. And if you are new in my channel, please subscribe to my channel and also like and share this video, and I will see you next time.